Hello and welcome to the Omnex webinar, Electric and Autonomous Vehicle Markets for High-Tech Industries and Automotive Standards. During this webinar, if you have any questions, please enter them in your questions dialog box located in the GoToWebinar panel, and the presenter will get to them at the end of the presentation. The presenter for today's webinar is Chad Kymal, CTO of Omnex. Chad Kymal is the CTO of Omnex, an international consulting and training organization headquartered in Ann Arbor, Michigan, in the United States. Omnex has been working in the automotive industry for over 30 years, and Omnex principals have been active in writing automotive standards including QS 9000, ISO TS 16949, semiconductor supplement, APQP, FEMA, and core tools. Chad has spent over 20 years in system, hardware, and software development in various capacities. He addresses and works in the automotive system, hardware, and software for Agile, Automotive SPICE, and Functional Safety ISO 26262 Part 6. Chad is a certified lead auditor for IATF 16949, ISO 14001, ISO 9001, ISO 45001, AS 9100, ISO 1345, and he is also an INTAX certified assessor for ASPICE. Thank you, and you can take it away, Chad.
Miles, thank you very much. Hello, everyone. I've been giving this same webinar in multiple different places in the last 3 months. If you're in the automotive industry, or if you're associated with the automotive industry, what's happening right now is a very exciting time, full of change and really full of opportunity, and also decision making, so we make the right decisions. Okay, so even if you've seen this webinar, I've added a few changes to this webinar. The webinar 2 that we'd like to do in this series of webinars that we're planning to do for the safety, electric, and autonomous vehicle market is a deep dive into new product development. After that, what we're planning to do is to cover a webinar on ASPICE 26262, cybersecurity, SOTIF, and so on. So all of you can really understand what these standards mean and the changes to it. So let's get going here. So you all know Omnex was founded in 1985, about 33 years ago, and we focus on management systems, integrated management systems, Lean Six Sigma, and many other standards. One of the things I'd like to always point out when I do these webinars is about the global nature of Omnex and how we're able to provide services around the world for our customers, who need to, in fact, one of our customers with 26 different languages. All right, let's get right here to the webinar. The electric and autonomous vehicle market for high-tech industries and automotive standards. So what we'll do, we'll talk about what's motivating this change, the change towards safety, electric, and autonomous vehicles. I really lightened the next section on the AV and EV basics, and I'm planning to spend more time on the 7 pillars of electric vehicle and autonomous vehicles. And then we'll, close the webinar, and we'll take a few questions as time permits. Okay, so what is going on in this electric and autonomous car market? And simply said, it is countries phasing out gas and diesel vehicles. So here are some, from countries that have banned gasoline and diesel cars, from England, China, France, India, and so on. There's a whole nother list also, by the way. We just took some of them. So with this happening, what's also happening is GM has announced they're going all electric. They're going to phase out gas and diesel powered cars. Volvo, by the way, I happen to be in Sweden today as I do this presentation, where Volvo is pretty much in Gothenburg, where I am, is the company in where I'm at right now. So Volvo says it'll end gas-only cars, and Volkswagen, really, in the end of the day, if GM and Volkswagen, the two largest car companies, have announced that this is the end of the combustion engine and it's going to go electric, pretty much you can expect everybody else will follow, and they are. So let's look at the announcements that we're seeing. Here is the targets for the electric vehicle targets by OEMs. Look at FCA, 28 new electric vehicle models by 2022. I'll just jump. Mercedes-Benz, 10 new EV models by 2022. 25% of the group's sales that they're planning to do in 2025. And so on. Toyota, more than 10 new models by early 2020s. So it is very clear then that the car markets that we're talking about are switching from what we call ICE, or internal combustion engines, to electric vehicles. Well, it's not just that, but I'll tell you more as we go along. So before that, what has been happening, let's say for the last 10 to 15 years, is a tremendous amount of safety going into cars. And of course, it was all cemented by this announcement in 2016 between the US Department of Energy and 20 OEMs who, with the agreement to make automatic emergency braking systems, okay? Backup cameras. In fact, there's a number of innovations, from the last 10 years that have been rolled out, and I'll show you that a little bit later, that have come into the car. So what is this? At the same time this has been happening, the electric content in cars, when both hardware and software, has been increasing at a tremendous amount. So much so, between 2020, with about, let's say, 35% of the car being electronic, it's going to go as much as, 2030, 50% of the car being, hardware and software. A tremendous amount of, income or revenue being shifted from the traditional car makers to the, electronics, hardware, and software car makers. This is one of the reasons we're seeing a lot of new entrants that are coming into the automotive industry. As I mentioned in the, the abstract, the summary for this webinar, this is the most open time in terms of if somebody was trying to enter into the car market. This is the time, if you have the right technology, the right innovation, and of course the right management systems in terms of being able to produce functional safety, cybersecurity, ASPICE, this is a wide open field for companies who are able to do that. So, safety coming into the car, the electronic content increasing in cars, course, what can you expect? At the same time, what the car companies are seeing is an increase in the number of warranty recalls due to software. You know, those numbers says 15%, and it goes back to 2016. I did some work with a truck OEM, and what they told me is they're seeing much higher percentages in terms of software recalls. In fact, he said 50% of their recalls are software related. So software is coming to be one of the key areas that the automotive industry is focusing on. And so you can just imagine that's why we're seeing things like ASPICE and, of course, Part 6 in ISO 26262. All right, let's move on. So going on, you know, in terms of understanding the shift into electric vehicles, suddenly you're seeing all these global alliances and agreements happening. So what is the bigger picture of the change that's happening today? The bigger picture, of course, is that electric vehicle is one of the, you know, it's where the car industry is starting with the goal, of course, going into autonomous. In fact, we facetiously say in the conferences for autonomous vehicles that we're a part of that there's a gold rush on. And indeed, the car company that's able to come up with a level 4 or level 5 autonomous car really is going to clean up. It's a huge amount of revenue. Excuse me. In fact, 1.5 billion is what we're looking at in terms of the autonomous car market. And so now you can understand what is going on with these global alliances and agreements is what we call the traditional OEMs, the new OEMs like Apple, like Waymo, which is Google, and in fact, a number of different Chinese companies also all getting into the electric and then autonomous car market. In fact, when you look at this, you can see both hardware companies, software companies, and automotive OEMs. So that's one more thing, of course, is that you see the Ubers and the and the Lyfts joining in, and the reason being, of course, is that when the car market goes to level 5 autonomy, the what they call, in terms of the Uber and Lyfts of the world will suddenly gain a lot more power because it's going to be going into a as a service where they're seeing the car public buying less cars and then using car services more. Okay, let's go on. So global alliances and agreements. One of the other things I didn't mention to you also was that the cost of going autonomous is a tremendous amount of money. So a lot of companies are working together. So you're seeing Volkswagen and Ford work together. You're seeing a Fiat working with Aurora. You're seeing Toyota working with Uber and let's say SoftBank. And the reason is it's going to take a tremendous amount of, hundreds of millions to go from level 2 to level 3, level 4 to level 5. And I'll explain that a little bit later when we get to that section. And simply said, when you go to level 5, there's what you call different scenarios. When we get to SOTIF, we'll talk about the scenarios that have to be thought out so that a car is able to handle all the different kinds of events that can happen both in city driving, highway driving, and others. Okay, so some thoughts here for us. What are the implications of the shift to EV and AV? Okay, what does this mean if I'm a OEM? What does it mean if I'm a tier one? What does it mean if I'm a sub-tier? So in the end of the day, we have to look at the products we offer and ask the question, will these same products be the products that go into electric vehicles and autonomous vehicles? This is the time, folks, where we have to position ourselves, look at our product mix, and decide, what we're going to supply in the future. Not only tier ones, tier twos, and tier threes, also companies like Omnex. We're doing the very same thing. And I can tell you this, what we're all doing needs to change, and also the competency of the people inside the organizations need to change and be upgraded to meet these requirements of EV and AV. So what is the role of software and electronics? In the end of the day, the amount of software and electronics is going up at a rapid rate. Organizations that are supplying mechanical products, if they already have not, have to bring in hardware and software competencies into their organizations. All future products will have both mechanical, hardware, and software. How about supply chains? Well, the supply chains are going to be the supply chains we have today, which means large supply chains extending from US, Europe, Mexico, China, India. And developing products is going to get even more complicated. I'll explain this in the next section because we have to design together. In fact, in just looking at functional safety, the ASIL is going to flow down from the system all the way down to a sensor or a semiconductor chip, which means these functional safety requirements at the very top, which flow down to right down to a sensor or chip level, all have to work together. So when one thing changes, the other thing changes. So there's a requirements flow down and a testing flow up. So the supply chain and working together as a supply chain in product design suddenly becomes very, very important. So that is really the implications of EV and AV to product development. And so I'll just mention it now, and it'll be half of my presentation a little bit later, will be what the new in product development. Suddenly we have to have the competencies of ISO 26262 functional safety, ASPICE, cybersecurity, SOTIF, and so on. We'll talk about that a little bit later. And I already mentioned to you, partnerships and agreements are only because of the tremendous investment needed, not so much for electric, but going from electric to autonomous. And this is what actually GM had announced was trying to save $6 billion to invest in this change towards electric and then autonomous. All right, so I think it's very clear to all of us what is then the motivation for all of us the OEMs going electric, and then of course for all of us in the supply chain, also being implicated and also having to change. So what then is the impact of these electric vehicles is the increased new technology, increasing amount of software and hardware. Let me just say, the electric vehicles of today are very, very connected. And when they're connected in this fashion, definitely there's cybersecurity. As soon as you talk about high voltage, and the power modules and the battery, a tremendous amount of functional safety needs also. And there's also supply chain. And so electric vehicles then are going to need a number of new competencies, new technologies. What about the autonomous car? So here is a level 1, level 2, level 3, level 4, level 5, a different look at it from just the SAE standard level 1 through 5 sheet. So let's look at the bottom here first, the dates people are predicting. I can tell you right now, we're almost at 2020. Cars are not at level 4, are not going to be at level 4 next year. The folks who are the closest, of course, and who are getting a lot of the accolades are Tesla, of course, and with the autopilot, and also General Motors. General Motors with the Super Cruise, and especially the performance in the highway. And General Motors, though it's gearing up for a lot of electric cars, are going in this right now, are using the Super Cruise, features in a mechanical Cadillac. Okay, it's a mechanical car is what I meant to say. So when you look at this going from level 1 through level 5, look at the tremendous amount of sensors and hardware needed. And of course, back this up, there's a tremendous amount of software also that's going to be needed as we go to level 4 and level 5. Because we are working squarely in this industry right now, I can just tell you the vehicles that we're working with are really right now in level 3, working towards level 4. So what is the difference between level 4 and level 5? Level 4 is autonomous within a certain operational definition. For example, it could be a vehicle going in a circuit around a university, moving students. It's autonomous, but it's moving students between a certain set route. That's a smaller scope, and it's a smaller operational definition, what they call ODDs. Another example might be autonomous car or vehicle operating within a shopping center. Okay, those are some examples of level 4, or just a vehicle operating autonomously in the highway. So of course, going from level 3 to level 4 is going to be a big deal, but then going from level 4 to level 5 is even a much bigger deal, because a level 5 vehicle is going to be able to operate in any different environment. All right, so the idea of going from level 1 through level 5, and just take a look at what has happened in the last so many years. So remember I talked to you about ADAS, the active safety and driver assistance. Look at the number of safety features that have come out, and come again in 2016, and then you're looking at 2018. You're seeing a lot of things with the in terms of highway driving, right? And then in 2021 is when they're seeing the advent of what they call the disruptors, with Waymo, Lyft, and Uber and Apple coming in, and so on, where we don't really know exactly when the level 5s will come in. But I'll tell you, there'll be a great market for level 4 vehicles itself, and it is going to change things in a big way, even if you get a level 4 vehicle, especially in highway driving. It's something maybe we can take off and discuss at another time what that means. but this is the roadmap, and this is what everybody's working towards. And I can just tell you this, whoever reaches level 4 and level 5 is going to clean up. And even if they get 1 year, before anybody else, or 2 years or 3 years, if it's 5 years, you can see that they're going to become some sort of a monopoly player in the market. All right. So what we were trying to say is the motivation and what is happening in this automotive market, why companies are going electric, and then on top of this electric, they're going to be building the autonomous vehicle, the level 3, the level 4, the level 5 autonomous vehicle. So what Omnex has done is taken a look at what this means in terms of management systems and product development, and we have defined what we call the 7 levers for the automotive industry. And we know IATF 16949 and maybe ISO 26262 to some degree, but there's a number of other competencies we're going to have to embrace. Folks, today I'm not going to get a chance to talk about everything. I'm going to talk about 5 of these. I'll be not talking about supply chain practices or Agile APQP. And Agile APQP, by the way, I'll just mention to you, is the use of Agile, which is for software, but using it at scale in an automotive environment, the APQP environment. So 1. So we all know IATF 16949. Most of you who are listening are probably IATF certified right now. Why we have it here is to say this IATF 16949 and the core tools are going to need to change. So just in this APQP, let's look at the bottom here. What is the impact in terms of APQP? So what we're saying is systems engineering with the architecture of system, subsystem, hardware and software architecture, with the requirements flowing down between the system, subsystem, hardware and software, the traceability requirements and the engineering V model and designing in concert is going to fundamentally change new product development. I'll say this, really phase 2. Folks, we have written a white paper on this subject. Please talk to your Omnex representative and get this white paper, which really focuses on product design and development, the impact of product design and development using these 7 levers that we're talking about. But the first, item on the 7 levers is the IATF 16949 and the core tools, and we're just mentioning as we go forward to the next different competencies that APQP itself is going to have to fundamentally change. Okay. So what are we going to have to incorporate into this APQP? We're going to have to incorporate and link, because some of the software and hardware could be with our supply chain. Keep that in mind, and keep in mind also that building a system or a subsystem in at a tier 1 level is way more complicated than 4 levels that we show here. So what are we saying? Well, that we recommend that the DFMEA with the DVPNR link be used so that you can have the systems flow down. And folks, you can do the systems flow down. It's built into the AIG VDA, or you can do it to the 4th edition, but you're going to have to use the flow down mechanisms that software like Omnex's software has built in. And if you do it like that and you bring in all the different players, automatically the system requirements, the subsystem, software and hardware will flow down. And doing the DFME and the DVPNR, automatically you'll get test plans which will do the test flow up. All right, which is the idea of the requirements decomposition on the left side and the testing build-up on the right side, the integration on the right side, which is what makes up this model V, or the V model. All right, so that's the first section, just saying that the IATF 16949 and the core tools are going to fundamentally need to change because some of the requirements of these other systems that we're going to talk about. The second one we're going to talk about is this automotive SPICE. Automotive SPICE, we always say, pardon me, is a framework for software. But in the end of the day, it really links systems. It's got requirements for systems processes and software processes, all right? And I'll explain that to you a little bit more. But Automotive SPICE, as you all know, gets pulled in through embedded software requirements in IATF 16949. Pretty much, we have two options. We can do CMMI or Automotive SPICE. And the reason Omnex is talking to you about Automotive SPICE is that, you know, the European OEMs are using, are requiring Automotive SPICE. And so is also Ford Motor Company and FCA. I really haven't checked in with GM, but pretty much all the OEMs are going Automotive SPICE. So really, Automotive SPICE is the option to use for embedded software. So let's take a quick look here what Automotive SPICE is all about. It's a disciplined process for new product development. Let me go to the slide after this and then come back to this slide. So really, I hope my numbers aren't off. There are 32 different processes. And then there are 16 processes in this HIS scope. Let me just check that again. And you can see in the systems, the systems V here, there are 5 processes, but only 4 in the HIS scope. In the software V, we have 6 processes. That's 10. There are 4 processes here in the supporting processes. That's 14, 15, and 16. So 16 different processes which are in the HIS scope, which is what the OEMs are asking for at a minimum. All right. They're saying a level 2 ASPICE requirement with this HIS scope. Let me just go back to the previous slide and just say just to give you a different view of that very same engineering V, when you look closer, you see SIS2, systems requirements analysis, flowing into the architecture analysis of the system, then going to software design, software architectural design, and then unit design. And on the right-hand side, you see the unit testing at SWE4, the integrations testing of the modules of the software, and SWE5, which is software engineering 5, or the qualification test, SW6, and then building it into the system. So I hope it's clear to you that when you talk about Automotive SPICE, it's system requirements and software requirements, all right? And as you look at this, you can see some new processes that's not in IATF 16949, like configuration management. And by the way, configuration management is not just for product, it's for also all the work products, all the records. You can see overlap with IATF 16949 soon as you say problem resolution management, change request management. These are processes we already have in IATF 16949. So as to the most important part is process in ASPICE is MAN3, or project management. Okay, all right. So we have all these processes, and what I mentioned to you is that the customer wants at least a level 2 ASPICE requirement. So let's try to understand what this means. Well, if you have no processes in place, you're at level 0. if you have each of these processes have something called base practices, anywhere from 6 to 8 or 9 different practices that have to be implemented. And if you have them implemented, you are a level 1. Then on top of that, if you're planning your process and planning the work products, you are a level 2. Okay, that's managed. So up to level 2, you can practice in your projects, but to get to a level 3, you have to have an organizational definition of processes. All right. Suddenly, it's a standardization of the ASPICE processes with something called tailoring built in. So really, the customers today want us to go to a level 3. But keep in mind, many of you are thinking it's just your software groups that have to be brought in. You have to realize it's not just software, it's also the system and the software, okay? And that system is at the highest level of IATF 16949, clause 8, especially 8.3. All right, so what we're seeing here is I've just drawn for you phase 2. Everything has to be lined up in phase 2. Why? Because requirements flow down and then testing flows up. If testing has to flow up, my software testing has to finish and be integrated into the hardware and software, integrated into the subsystem, into the system. Do you get that? So we have these V's going on in phase 2 of APQP. All right? All right. Next, one of the things we said would, we have this, let's say we have the system, hardware, and software. I took out the subsystem so it's not confusing. And just to say, ASPICE is for the complete system. ASPICE covers the entire product design process for system and software. Okay? And on top of this, we're going to build 26262 and the rest of it. And let's go on to the next section, which is ISO 26262. ISO 26262, Omnex started practicing in 2009. The standard came out in 2011, and here we are in 2019. And I was just in the Omnex's Berlin office, yesterday, and I'm going back there tomorrow, or day after tomorrow. And people are practicing and building, safety products without 26262. As a hindsight, companies are calling us in to do assessments quite late in the game, and we're finding a tremendous amount of things missing. Okay, so even though 26262 has been here for a while, people have just not implemented it. What is ISO 26262? Well, it was actually brought in, as I mentioned, in 2011. I forget when the Toyota incident for braking took place. Soon after that, the boards of different companies, automotive companies, were shocked about the tremendous loss of, the value of the stock for Toyota after that publicized hit in terms of braking. Toyota lost money for the first time in its history, in the recent history, we'll say. And ISO 26262 was fast-tracked. We had expected it to come out maybe much later, but it came out in 2011. And why? You saw this graph on E&E, the amount of electronics and software. So there's new functionalities, increasing content in electrical and electronics and software. And that's the focus of ISO 26262, to deal with this technological complexity, the software content, and what we call mechatronic, the mechanical and electronics implementation. And what's the big deal? The big deal is the systematic and random failures that we're going to see versus single point failures we saw in the past. Well, more about that later. So ISO 26262 then addresses hazards caused by malfunctioning behavior of this E&E safety related system. So the scope is product safety, and it's about electronics and electrical and software. Okay, it's a narrow scope. What does it not address? It doesn't address hazards related to electric shock, fire, smoke. These are the byproducts that could happen. Okay, it doesn't address that. And then look at the bottom there. It does not address the the nominal performance. So after the designer is finished with the functional design, if there's any design defects in the function, or if there is opportunity for misuse, it's not addressed in ISO 26262. That requirement has been given to SOTIF to sort out. We'll talk about that in a second. So pretty much what you're seeing here is, I like to tell people, part 2 and part 8 align with IATF 16949. Part 3, the concept phase, is entirely new, that we don't have at all. It needs to be added in. The whole idea of item definition, HARA, and the safety goals and the functional safety concepts. Folks, those of you are saying, well, that doesn't apply to me. You have to, even at a chip level, you have to define it as what is called a SEOC, safety element out of context. Okay, have to be defined in the concept phase with assumptions on the hazards at the system level. All right, once you do that, part 4 is system, part 5 is hardware, part 6 is software. And all of that aligns with phase 2 of APQP. All right. And of course, today we have the part 11, the semiconductor guidelines, and also guidance for motorcycles. So how should we think about ISO 26262? ISO 26262 is a subset of the product requirements. Okay, ISO 26262 has a lot of additional requirements for the subset of requirements in system, hardware, and software, and definitely has overlap there with ASPICE. All right, let's go on. Next, we have SOTIF. SOTIF is the 21448. It's a publicly available standard, so it's a guidance standard. After the designer is done, it deals with the resulting functional insufficiencies. Let me give you an example of insufficiency. This is not a safety example, but you'll understand. In fact, we had just finished ASPICE assessment of what is called a kick sensor. Are you all familiar with the kick sensor? You go to the back of the car by the trunk area and you kick, and the trunk opens up. All right. So I've just bought a brand new car. I have this habit of putting my keys into the briefcase. So I walked up to my brand new car, kicked it with the kick sensor, and boom, it sensed I had the key in my pocket, in my briefcase actually, and it opened up. I put the briefcase in, I kicked it again, and the trunk closed. Now I go to the door and I try to open the door. The door will not open. So I go back to the trunk and try to kick it again, and it won't sense it. Wow. Now, do you understand the idea of functional insufficiencies? Here's a kick sensor working perfectly fine, but the product designer didn't think about all the different scenarios of use. You understand scenarios also now? All right. So there's some functional insufficiencies. I have several examples of that. Why I like to talk about um, a small development like a kick sensor is to tell you SOTIF is there for any kind of subsystem of a car's development. All of us think of it in terms of a OEM, and yes, why we think of it as an OEM requirement, going from a level 3 to a level 4 to a level 5, it's all sort of, folks. The idea that the car should be able to, meet all the different scenarios, in terms of city driving, highway driving, etc., is scenarios. But scenarios are there also for the small subsystems. So what is a scenario? A description of what they call temporal development between several scenes in a sequence of scenes. Each scenario starts with an initial scene, yes, key in a briefcase, walking towards a car, kicking it open, putting it in. Okay, all that is a scenario, all right? And there's a triggering event, a specific condition of a driving scenario that could serve. Remember, this is about safety. And my example was not about safety, but it was about a scenario where the designer didn't think of and then didn't design the kick sensor correctly. But in this case, it's a driving scenario that serves as an initiator for a subsequent chain reaction leading to a hazardous event. What's the example? While operating on a highway, the car misreads a road sign as though it needs to brake. The emergency braking system comes on, making the car stop in emergency, maybe even the airbag going off. Okay, so it's a very unsafe situation to be in, and it's a scenario that resulted from a misidentification of a road sign. All right. So SOTIF and ISO 26262, I put in the same subset. Of course, it's a different set of safety requirements, and for whatever reason, well, SOTIF also has a different set of criteria for defining testing required for it. Otherwise, pretty much what Omnex is going to be doing is to take the SOTIF requirements and put it part of the functional safety requirements, and of course allocate it flowing down into the subsystem and the hardware and the software, very much similar to ISO 26262. But ISO 26262 has something like 16 tables in hardware and 18 tables in software in terms of the requirements for the design of the requirements and the testing. SOTIF has much less. Okay, all right. So 26262, SOTIF, and ASPICE. And folks, I'm running out of time. The next is cybersecurity. And let me just tell you, right now, that's SCE J3061. We're on the writing committees of course, we were on the writing committee of 26262. We're joining back again. We're on the writing committees of SOTIF and ISO 21434. So we already have training for 21434, and we have a integrated training with SAE J3061, which is guidance, and SAE 21434. Why? The car is indeed very, very connected, from cellular phones to internet to cloud to maps, in terms of and then also for connecting to somebody helping us if there's an emergency and so on. So what we have is a tremendously connected car, and it's going to get even more. What's going on? Well, there's a lot of threat in the landscape. Well-financed attackers, individual hackers, amateurs, insiders inside our companies, all trying to come in or not come in, but to break in and do malicious acts. So we have this 21434, very similar to ISO 26262. It has a concept phase, it has a product development phase with system, hardware, and software allocation and development. Taking a look at this, just like we have the HARA for the HARA leading to the functional safety concept, for cybersecurity, we have a threat and risk analysis leading to a cybersecurity concept, to the cybersecurity requirements, to system requirements, and of course, the system requirements get allocated down. What we wanted to show you is that the functional safety requirements and cybersecurity requirements go into the overall product requirements and then will get allocated, okay? And the biggest difference between cybersecurity, and the functional safety, of course, is one is safety, one is cybersecurity threats, one is hazards. But, cybersecurity threats could become safety issues, all right, number one. But the biggest difference is that once you've designed a safe car, you're finished. With cybersecurity, the hackers are getting more and more clever, and they, in terms of trying to break in. So cybersecurity is never finished. You have to continue developing your defenses against cybersecurity hackers as an ongoing, and you have to download it to the car with an OTA. So this is how we showed it for cybersecurity, the idea that there's an overlap with functional safety, but then hardware and software will take up, a big part of the overall requirements of a vehicle. And we also wanted to share with you that, ASPICE is everything, but functional safety and SOTIF and cybersecurity are a portion on a subset of the requirements. And certain things like configuration management, traceability, change management will be for all the requirements, but for ASPICE 26262 and SOTIF, there are very specific ways we have to identify the requirements, identify the test cases, and how we do testing. Okay, keep that in mind. That's the implication of these standards. So 21434 is still under development. We expect it to be out next year, and you will have to tailor it, or the idea was we'll have to implement all the requirements. Tailoring will be acceptable, or some sort of rationale in terms of why you didn't do something to it. So with that, we've covered 5 of the 7 different levers of the impact of EV and AV in terms of the automotive industry. And let me give you a pause before I go and finish and summarize this webinar I'll try to take at least 2 questions. Okay, so with that, what we'll do, let's summarize this webinar. What are the points we can make? What are the conclusions we should draw? What should we take away with us? Number 1, the product change from gas and diesel to EV and AV, electric vehicles and autonomous vehicles, is inevitable. Things are in motion now, folks, and the challenge and the opportunity of autonomous vehicle is tremendous. That I mentioned to you the gold rush, and so people are going after the gold. In China, there are actually 300 different car companies going after electric vehicles and autonomous vehicles. So there is going to be a big race to the finish in terms of, and the game is on. What's the second point? All of us, including the sub-tiers, will need to shift to EV and AV products. We need to look ahead and then, make sure we have the right products. And then for these right products, you need to have the systems engineering, the competencies for your people. You need to have, which is the point I wanted to make. So let me make it now. When I showed you these pictures, you need to have, you're applying ASPICE, ISO 26262, SOTIF, and 21434 cybersecurity. You're applying it to the same product design. So it cannot be siloed. You have to integrate it, and you have to integrate this into the IATF 16949 APQP core tools base. Okay, that's really important that you keep in mind that your management systems need to change, and that's what the 7 levers here as a third bullet represents. EV and AV companies, and when we say EV and AV companies, we don't just mean OEMs, we mean all of you supporting electric vehicles and autonomous vehicles in whatever tier that you're in, will need to adopt systems engineering strategy with the use of software to develop products that incorporate APQP, FMEA, ISO 26262. So let me just say this. This is the big challenge Omnex has taken for ourselves, developing software that helps you do the systems engineering and this product design, integrating in what I just told you that needs to be integrated. In fact, we believe if you don't have software to help you do product development, it's going to be just, really difficult to be able to implement this in the supply chain, right? OEMs and suppliers who adopt a design need to adopt a design and process reuse strategy. So design reuse and process reuse means that once you get the design completed for functional safety or cybersecurity, you need to be able to reuse that strategy and design without developing it from scratch every time. And if you reuse it, then it'll lower your cost. Again, this is also something Omnex is working on, to thinking ahead how companies should do this. And OEMs and suppliers will need to integrate IATF 16949, including APQP, with ISO 26262, the SOTIF, the cybersecurity, and the ASPICE into their design and business processes. So this is, what are some of the key takeaways we'd like to leave you with. Before I go into the questions, just tell you that we have our IATF 16949 series, all kinds of different training, including the AIG VDA. Again, what is the advantage of the AIG VDA? Is the requirements flow down. A couple of things Omnex will say, that the requirements needs to be functions and requirements flow down, okay? Because then it'll fit into the DFMEA very well. And it has to be linked to the DVPNR, right? And you need to have software that's going to help you do that, like Omnex's Aqua, right? So training, we have an Automotive SPICE series. We have also added in an INTAX training course if somebody would like to become a certified ASPICE trainer. We have training for SOTIF, Agile, functional safety, lots of different training for functional safety, and cybersecurity. Okay, and I believe we also have a general class. We thought engineers might need an introductory class to autonomous and electric vehicles, or safety and cybersecurity perspective, or introduction to systems engineering. This is some of the competencies that are lacking today. So with that, what I'll do is take two questions that people have posed. Let me try to understand this question. How are these requirements being implemented in the various autonomous driving setups? So let me just mention to you that I'm seeing it implemented. They're not being implemented very well. In fact, I think maybe the German and the American OEMs are doing a better job than maybe OEMs in some other parts of the world who are trying to put in ISO 26262 a little late. In the US, I'm seeing a siloed implementation where product design, you have a separate functional safety group and a separate cybersecurity group. And fundamentally, we cannot do a good job if we're going to silo the effort. I'll just leave it at that. And just to say, this effort, it should not be just in the OEMs or the startups. It needs to be there also in tier ones who are doing safety designs. And many people are not even aware that there's a cybersecurity standard that needs to be implemented. I'll take the second question. Let me see which question I'll take. Here's a question about ASPICE. What are the similarities between ASPICE and ISO 26262? I'll say this, ASPICE integrates with Part 6 software in ISO 26262 and also with the system requirements in Part 4, okay? And that's the second question I'll take. And a new question just popped up that I'm sort of interested in answering. It's a continuation from the same listener. How can we educate the team and the suppliers about these requirements? So I'll just say this, if something like this, I'm happy to do something like this for inside of your company. If I'll do it for free, but of course I'll do it also come in person, because that'll have to be you'll have to do it as a regular training seminar from Omnex. But I am taking this effort now, as I mentioned to you, letting people know that these are the things that have to be implemented, because you're right, people don't know that this is what's needed at this point. Folks, I hope this was a good webinar for everyone, and we're seeing this as a start of our series. And of course, we do have it taped if you want to use this tape to help educate people inside your company. But I'm also very happy to do a free webinar for your company, or happy to come inside. I end up, I did for this very large electronics company, I did an executive overview a little while ago, and we and people inside the company knew that they were getting a lot of safety products, but they were not implementing these things, some sort of lack of understanding inside top management. So here I am halfway into the seminar on ISO 26262, and suddenly the president says, "You mean ASILs? ASIL means ISO 26262?" And I said, "Yes, ASILs mean ISO 26262. So I kept going, and 2 minutes later he said, "ASILs mean 26262? I said, "Yes, ASILs mean 26262. And then I went on for about 15-20 minutes, and he said again, he said, "ASILs mean 26262. So that was an eye-opener for the president. And also, I had come prepared because from the internal people to tell him that he had 10 projects and the number of projects were going up in, very sharply in terms of those that needed cybersecurity in 26262. So really, this is the level of understanding today. And, folks, part of your jobs to educate people. And of course, I'll also do my job. Okay. With that, thank you all very much. I'll sign off here from Sweden, and it's end of my day. And thank you all very much. Take care. Bye-bye, everyone.